in the oxidation reaction. So as you can see here, our lead solid is being converted into lead 2 plus, that is in lead sulfate there, meaning to say that our lead sulfate is being oxidized to lead 2 plus, and we have a loss of 2 electrons there. So which means to say that this one is an oxidation reaction. So we can actually write this one in our 10.3. What are we saying? We're having our lead solid being converted to lead 2 plus in aqueous form plus 2 electrons. This one in itself is an oxidation reaction. So we have an increase in oxidation number from 0 to plus 2, which is an oxidation reaction, right? Or we are losing 2 electrons there from our lead, therefore it is also an oxidation reaction. So in this case, our lead solid there is acting as a reducing agent. So this one is our reducing agent, right? Let us go to question 10.4. If we go to question 10.4, we are saying that one of the safety concerns related to the lead acid battery is the dangers associated with recharging, that is reversing the net reaction of a flat battery. Water in the battery can be electrolyzed to produce hydrogen and oxygen gas during recharging. Right? Use the table of standard reduction potentials and write down the half reaction which explain the formation of oxygen gas. Right? So in this case, we're having our water is being electrolyzed to produce hydrogen and oxygen. So our water there is being decomposed or broken down into hydrogen and oxygen. So if we go to question 10.4, we see to that from our standard reduction potentials, we have this particular reaction, that is we are going to have our 2 moles of water. We are going to have the formation of oxygen gas plus our 4H plus in aqueous form, and this one is a gas and this one is in liquid form, and we are going to add 4 electrons. So we have this one straight from our standard reduction potential tables, right? So now if we can add these 2, 4 hydrogen ions plus our 4 hydrogen ions in aqueous form plus 4 electrons, this one can give us hydrogen gas, right? So if we are going to look closely in our question, we can see that we are having the formation of hydrogen and oxygen gas from water. So that is what we have in our equation there. So we have our water is being decomposed to oxygen and hydrogen gas. So that is the answer to question 10.4. Let us proceed on to question 10.5. On question 10.5, the question says, why is the recharging of flat batteries a safe concern? Right? As you can see from our equations, we are going to have the formation of hydrogen and oxygen gases. These particular gases are produced during recharging, may explode if sparked. So there is need for us to actually do this particular recharging itself with all the caution. So let us go to question 10.6. right? In our question 10.6, the question says, if the cell capacity of such a cell is 3,5 ampere hours, calculate the number of electrons that flow through the cell in 30 minutes, assume the cell discharges completely during the 30 minutes. The charge on one electron is minus 1,6 times 10 to the power minus 19 coulombs. So we are supposed to change this 3.5 ampere hours into coulombs. So because this one is our capacity and the capacity of our cell itself is our charge. So what are we having? We are saying our charge itself is going to be equal to our 3.5 ampere hours times 60 times 60, so that we can change our 1 hour into seconds. So if we're going to multiply that one correctly, we are going to have 12,600 coulombs as our charge, right? But now we want to find the number of electrons. So our main aim is for us to find the number of electrons. The number of electrons is going to be equal to the charge which we have over the charge on the electron, which is 1,6 multiplied by 10 to the power minus 19, which is going to be equal to our 12,600 out of 1,6 times 10 to the power minus 19 coulombs. So at the end of the day, we are going to get our answer there as 7 point. Our answer is, so our answer is going to be equal to 7.88 times 10 to the power 22 electrons, right? So that is our question number 10, which we have been shown there. So thank you very much for your listening and understanding as well of the question. I hope and understand that this particular question is going to actually help you to apply some of the questions which are going to meet under the batteries in your examination. All right, so stay tuned for the third question in our examination type questions of our batteries.